So the following demonstrates the experiment performed in the laboratory cementation lab, and the experiment number 2 is regarding the construction of Lvdt and to draw the input and output characteristic of Lvdt to find its linear range of operation. So shown over here are the schematics of the Lvdt on the left hand side and the circuit arrangement on the right side. So if you look into the figure given on the left hand side, it comprises of 3 coils. One is the primary, and then there are 2 identical secondary, coil 1 and coil 2. Each of these coils are wound over a hollow cylinder, and the 2 secondary coils are connected together in phase opposition, and while this primary coil is given with an AC supply given by EI, and in fact this primary coil is wound over the hollow cylinder exactly at the center of the cylinder. Then there is a magnetic movable core which is allowed to move across the hollow cylinder, and this movable core is in fact provided with the displacement, or is displaced in order to have the coils at the secondary, the EMF induced in the coils at the secondary changed. So if suppose that the movable coil is moved on towards the right side, then the EMF that will be induced in coil 1 of the secondary and coil 2 of the secondary will be different, and thus this EMF, which is different in both these two coils, will be taken as the difference voltage at the output of the terminals given by the connections of coil 1 and coil 2. This can also be understood by the circuit diagram that is shown on the right side. So the difference voltage is shown, which is the difference between the voltages that exist between the two coils, coil 1 and coil 2 of the secondary, and this difference in the voltage is equal to the voltage induced in the first coil E01 minus the voltage induced in the secondary coil 2, which is E02. So now we will perform the experiment and show that when the Lvdt, the core of the Lvdt is moved, and here it is moved using a screw gauge. So for example, if the core is moved 5 mm, then the voltage that will be appearing across the secondary is 0.49 volts in the forward direction. So we are talking about the position of core versus output voltage for forward arrangement. Then for 10 millimeter displacement, we have the forward voltage existing as 0.98 volts. For 15 it is 1.47. For 20 mm it is 1.96. For 25 it is 2.44, and further for 30 we'll be having the voltage as 2.94. Then on further moving this, we see the voltage at 35 as 3.41 volts, and further moving the core 40 mm provides voltage of 3.89 volts. Then for 45 mm displacement it's 4.04, and for further displacement we see that the voltage gets, so it's a sort of saturation that started existing, and thus no further difference in the voltage would exist because the core must have crossed one secondary coil and is under the second coil only. Now if we try to understand the position of core versus the output voltage in the reverse direction. So now if the position of the core is moved by 5 mm, the voltage that exists at the secondary, the difference is minus 0.48 volts. For 10 mm displacement of the core, we have minus 0.95 volts. For 15 mm it is minus 1.46. For 20 mm this is minus 1.95. For 25 this is about minus 2.44 volts. Then for 30 mm this is minus 2.92. For 35 this is minus 3.44. And finally for 40 mm it's minus 3.93, and beyond this the core gets saturated. So now you'll have to submit a report plotting the graph using the both forward and reverse readings, and then you'll have to comment on the graph. The second question is to write applications of Lvdt, and third is what are other transducers that are available for displacement measurement.